Hi all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. In this video, let us see about decoder. In digital electronics, a combinational logic circuit that converts an n-bit binary input code into m output channels in such a way that only one output channel is activated for each one of the possible combinations of input is known as a decoder. In other words, a combinational logic circuit which converts n input lines into a maximum of 2 power n output lines is called as a decoder. So this is shown in the diagram here where we have n inputs and 2 power n output lines. Let us see 2 to 4 line decoder. In the 2 to 4 line decoder, there is a total of 3 inputs A0, A1 and E and 4 output lines, that is Y0, Y1, Y2 and Y3. For each combination of inputs, when the enable input is set to 1, one of these 4 outputs will be 1. So the block diagram and the truth table is as follows. So in the truth table, if the enabled input is 0, whatever may be the inputs A0 and A1, you will not get output in any of the 4 outputs as shown here as 0, 0, 0, 0 in Y0, Y1, Y2 and Y3. When the enabled input is 1, 4 combinations are possible 0, 0, 0, 1, 1, 0 and 1, 1 for the two inputs A1 and A0. So when enable input is high and A1 and A0 is 0, 0, the output Y0 will be 1. When enable input is 1 and the input combination is 0, 1, the output Y1 will be 1. And when the input combination is 1, 0, along with the enable input as 1, Y2 will be 1. And finally, when all the inputs enable A1 and A0 are 1, Y3 combination will be 1. So the equation is as follows. Y3 is equal to enable input into A1 into A0. Y2 is equal to E into A1 into A0 bar. Y1 is equal to E into A1 bar into A0 and Y0 is equal to E into A1 bar into A0 bar. So the logic diagram for this 2 to 4 line decoder is shown here. So you'll be using NOT gate and AND gates here in order to get Y0, Y1, Y2 and Y3. So you'll be having 3 inputs, enable and to A1 and A0. Next one is 3 to 8 line decoder. The 3 to 8 line decoder is also known as binary to octal decoder. In a 3 to 8 line decoder, there is a total of 8 outputs Y0 to Y7 and 3 outputs A0 to A1 and A2. This circuit has an enable input E. Just like 2 to 4 line decoder, when enable input is high, one of these 4 outputs will be 1. So the block diagram of a 3 to 8 decoder is shown here where you are having 3 inputs A1, A1 and A2 and you have 8 outputs Y0 to Y7 and also you have an enable input E. So when enable input is 0, whatever may be the input combination, output will be 0 for all the 8 output lines. When enable input is 1, you'll be having 8 combinations 0, 0, 0 to 1, 1, 1. And whenever according to the order, you'll be getting Y0, Y1, Y2, Y3, Y4, Y6, 5, Y6 and Y7 as your outputs correspondingly for each and every combination of the 3 inputs A3, A1 and A0. So this is the equations for Y0 to Y7 based on the input combinations and the logic diagram is as follows. So Y0 is equal to A0 bar, A1 bar, A2 bar. Y1 is equal to A0, A1 bar, A2 bar. Y2 is equal to A0 bar, A1, A2 bar. Y3 is equal to A0, A1, A2 bar. y4 is equal to a naught bar, a1 bar, a2, y5 is equal to a naught, a1 bar, a2, y6 is equal to a naught bar, a1, a2, y7 is equal to a naught, a1 and a2. Hope you understood decoder. So it is the inverse of encoder. So let us take up some assessment questions. A decoder converts n inputs to dash outputs. The options are n, n square, 2 power n, n power n. Yes, the answer is 2 power n. Decoder is constructed from dash. The options are inverters, and AND gate. None of them mentioned above. The answer is inverters and n gates. Thank you for watching this video.